Magandang araw sa inyong lahat, and this time I am going to discuss about the loads and reactive forces. External members such as beams are acted on by external forces that consist of a loads and the reaction forces developed by the beam support. There are two types of loads commonly occur on the beams and that are called concentrated load and distributed load. A concentrated load is assumed to act at a definite point. Such a load is that caused when one beam supports another beam. A distributed load is one that acts over a considerable length of the beam. It is if the distributed load exerts a force of equal magnitude for each unit length of the beam, it is known as the uniformly distributed load. The weight of the beam is a uniformly distributed load that extends over the entire length of the beam. However, some uniformly distributed load or loadings supported by the beam may extend over only a portion of the beam length. The reactive forces, these are the reactions that are upward force acting at the supports that hold in equilibrium the downward forces of loads. So the left and the right reactions of the simple beam are usually called reaction 1 or R1 and R2 respectively. So the determination of the reactions for simple beam or beams is achieved with the use of equilibrium equation for parallel forces. Say for example, if we have a 9,000 pounds concentrated load and at having a distance of 10 feet from R1 and 8 feet from R2. Okay. So this time, this is a unsymmetrical structure. No? So we're going to use the summation moment. Since we're going to solve for R1, so our pivotal point is at R2. So that's why we have summation forces, a summation moment at R2 is equal to 0, positive clockwise. So that is equal to 0 is equal to R1. So R1 positive because clockwise ang iyang direction. Okay? Times 18 feet. 18 feet is the perpendicular distance of the force which is R1 from the pivotal point. Okay? Which is R2. Okay? So minus 9,000 pounds. Negative, it is because the direction is counterclockwise. Okay? So the distance from R2 is 8 feet. So times 8. So we have 9,000 pounds times 8 feet divided by 18 feet. So the reaction is equal to 4,000 pounds. Okay. So we have now R1. So we're going to solve for R2. So this time, we're going to use the summation forces vertical kasi we have only one unknown. Okay. Is equal to 0 positive upward direction. So this is equal to 0. I mean 0 is equal to R2, which is our unknown upward direction, positive, plus again positive R1. So we have 4,000 pounds minus 9,000 pounds going down ang uh, load, concentrated load, so negative siya. Okay, so transpose lang siya. So R2 is equal to 5,000 pounds. Okay, so we have now R1 and R2. Okay, so R1 is equal to 4,000 pounds and R2 is equal to uh, 5,000 pounds. So if we are going to total this one, no, so this is equal to 9,000 pounds. That is equivalent to our concentrated load. So this is in equilibrium. Okay, so what if the load is in a uniformly distributed load? Okay, so we have a 900 pound per foot having a span of 10 feet. Okay, so hindi siya It is not the entire length of the beam, so portion lang of the beam. So it is also considered as a uniformly distributed load. So 10 feet, then the load is 900 pounds per foot. Okay? So the same procedure, so solve for R1, our pivotal point is R2. So equation, summation moment at R2 is equal to 0 positive clockwise direction. Okay. So 0 is equal to R1. Okay, R1 positive clockwise. So times 18 feet again. Perpendicular distance minus 900 pounds per foot times 10. Okay, so we're going to multiply it by its span. Okay, para magiging total uniformly distributed load. Okay, from a uniformly distributed load to a total uniformly distributed load. So we're going to cancel feet in this time, no? Okay. Times the distance. Okay? So, why nagiging 13 siya? Bakit nagiging 13? It is because ang distance ng uniformly distributed load is the center, no? Or middle of the uniformly distributed load. So, since we have 10 feet na span na uniformly distributed load, so ang middle niyan is 5 feet, no? So 5 feet, 5 feet. So that is 8 feet plus 5 feet, so that is 13 feet. Okay? So that's why nagiging 13. 13 is the perpendicular distance of the force. Okay? And that is equal to 900 pounds per foot times 10 feet times 13 feet divided by 18 feet, and that is equal to 6,500 pounds. Okay, and then we're going to solve for R2. So, madali na lang. So, we have only one unknown na lang siya. So, we're going to use summation forces vertical is equal to 0 positive upward. So, 0 is equal to R2 plus 6,500 pounds. Okay, na R1 minus 10,000 pounds per foot times 10 feet kasi you're going to cancel this one. So wala na siyang wala nang distance kasi kasi ang equation is not moment. Okay? So summation forces lang. So this time 10 feet lang kasi we're going to we're going to convert this uniformly distributed load to a total uniformly distributed load. So kung mapapansin niyo, makancel out ang feet, so pounds na lang siya. So 0, R2 is equal to 2,500 pounds. So we have a R1 na 6,500 pounds and R2 na 2,500 pounds. Okay? So that's it. And that ends my presentation. Thank you very much and God bless.